Okay, welcome to the base conversion episode or episode 1 in the UILCS written course. We're starting off with base conversion because that's the first thing you'll be tested on in any written test for UILCS. No matter what, you'll always have this base conversion question that'll always be your first. It's important you can get it right so you can just easily get 6 points off the bat. But it can also be confusing to a lot of people and can also be tedious and take a long time. So I have some methods, some ways to make it faster. Okay, so let's just start simple and talk about the number systems in general. The first number system is the decimal number system, or you might see this as base 10. Okay, I can't write. So you could see this as base 10 too. They mean the same thing. And you know what? Let's write 10 in this blue. Okay? So, now what is the decimal number system? Well, it's a number system that you use all the time. It contains 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so yeah, as you can see, we have 10 numbers here, right? Decimal, 10 numbers. Now, what does number system mean? Well, all that's really saying is you can use these individual numbers to construct any number you want, right? Like, for example, 11 is just two of these numbers. 122 is just one of these, two of these, right? That's what number system means. That's why we have it. And it's also in base 10 because there's 10 numbers. Now let's talk about the binary number system. And let's write number system out just so maybe if I want to post this, like the paint thing, it'll be easy to understand. So binary only contains two numbers, and it's also referred to as, subsequently it's referred to as base 2, okay? Because it contains only the numbers 0 and 1. So unlike in decimal, where we could use all of these numbers to construct any number we wanted, in binary we are limited to just constructing our numbers out of zeros and ones. That's it, that's all we get, okay? And the reason it's important you learn binary in computer science, that's why you're taught it in computer science, is because this is the number system computers use, which makes sense, right? It's smallest, it's easiest for a computer to understand, right? It's generally just ones and zeros. And also if we do engineering courses, this could be like on off for a gate, and this could be an on for a gate, or something like that, an on for like digital electronics and stuff. And we'll get into a bit of DE later on, because you have to know some for this course, right? But there's two numbers here, binary, base 2, 2. One thing I want to point out, if you're writing a binary number, the reason you'll know if you'll know the number is in binary, because it'll have numbers, right? But it'll also subsequently have a 2 here. Now you might be asking, hey, in the decimal number system, if I write 135, do I have to write a subscript 10? The answer is no. In fact, because we use the decimal number system so commonly in our lives, that we assume it's the automatic number system. So when you see 135, just assume it's in base 10, okay? And in the ULCS test, they might just have 135, no subscript. Refer to that as base 10, okay? Unless, I don't know, they say otherwise, some problem or something, I don't know. But yeah, commonly no subscript, or pretty much always no subscript, base 10. Just wanted to make sure that point was clear. Now, the next one that's really common too, well, for the ULCS course, it's gonna be the octal number system. And you can start to kind of pick up a pattern now, right? Octal, 8. Octagon has 8 sides, that kind of thing. Here we're gonna write in base 8. And I want to ask you, pause the video and see if you can figure out. If it's 8 numbers, how many numbers are we gonna have to work with in our number system? Okay, that's kind of stupid, but like, maybe here, I'll say it like this. What are the numbers that we're gonna get to work with in our number system? Like, what are the numbers that we're gonna use for base 8? Well, here they are. Hopefully you paused. 0, 1, 2, 3, 4, 5, 6, 7. That's really unfortunate. Yeah, I'm just counting because I'm kind of bad at math. Yeah, that is 8. Okay, cool. Here we have 8 numbers. So, and again, number system just means we can construct any number we want with these 8 digits. So in binary, we're limited to 2 to create numbers. In decimal, we had 10 to create numbers. And in octal, we have 8 to create numbers. And of course, that is green, that's not blue. You're going to need your subscript 8. The only one that can get away without a subscript is decimal. Everything else, you must have a subscript for, okay? And we're running out of room here, so let's just scrap this for now. And move on. I want to talk about one more. Because the rest, if I was talking about base 3, base 4, base 5, if this follows this same pattern we've been talking about, right? But what happens when you get past 9, right? Like you've seen decimal, it stops at 9. How would you represent like 10? What if you had 16 numbers in your number system? Well, we actually call this number system a hexadecimal number system. So I'm gonna write it out. And why hexadecimal? Well, I mean, I always looked at this hexagon has 6 sides plus decimal, which we know here is 10. Hexadecimal is 16. So hexadecimal number system. Okay. Oh, that's a whole word. Y. System. So let's write it as base 16. That's how you're gonna see it. The subscript is gonna be 16. Okay. Now, what are the values here? Well, you're gonna have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and here I'm gonna change color a little bit. Let's make it this, ooh, red sounds cool. We're gonna have A, B, C, D, E, and F. So A, where did it go? Oh, I'm on the wrong tab. Okay, sorry. A representing 10. Okay. B representing 11. C representing 12. D representing 13. E representing 14. And F representing the number 15. And I think one thing that's kind of interesting to notice is that all these number systems stop right before their number, right? We are in the decimal is base 10, but the last number you're allowed to use here is 9, right? Binary is base 2, but the last number you're allowed to use is 1, right? You can only use 0 and 1 to make numbers, not 0, 1, 2. Yeah, and then over here, base 16, oh, well, you stop at 15, you know? I think that's kind of interesting. Which, I mean, makes sense because we started at 0. That's not really related to the course, I don't think, but I think in general it's just a good thing to know. Anyways, so yeah, this is essentially how it works. There is no 10, 16. Why is there no 10, 16? That's a good question. Well, because if you're writing 10, 16, how would a computer know that you're not just trying to write 1 and then 0, you know? like how in binary, how you could write it like this, right? Where each of these just being one individual number. How does the computer know that, hey, the user means 10, the actual value 10, not 0, 1, you know what I mean? The only way we can, because the computer's not a genius, it can't like interpret our thoughts or anything. So we use letters like A, singular letters, and assign them a value of like 10. So the compiler, the computer understands, hey, when I see A 16, I understand that's 10. Okay. And just quick note, this pattern would continue if you went like base 20 or something. You're gonna have E, F, G, H all the way up. Now I don't know what happens when you reach C. I do not know that. I won't lie. But you won't be tested on that in the UIL CS test. Okay, so we've gotten an introduction into some important number systems. Now, it's important you understand these number systems, the numbers that are in them. Now, the next thing I want to go over is kind of the name, base conversion. If you were in base 10, how do you convert a base 10 number like 135 into a base 2 number? Or, I'll say I don't say subsequently, I'll say consequently this time. If I want to take a number that's in base 2, right, that's just made up with a bunch of ones and zeros, and I want to convert it into a number in base 10, how do you do that? Or if I want to take a number in base 2, convert it to a number in base 8 and vice versa, how do you do that? This is an incredibly important thing to learn because, well, this is like literally the first question will definitely have base conversion for you to do. And I'm thinking of having practice sections at the end of each concept, not in this video, but in like a future one, where I actually just go over some practice problems, one from district, one from regional, and one from state, over the topics. So then you can kind of see what I mean, why base conversion is so important. Or why you'll be pretty much forced to do it in every single problem over basis. But okay, let's start simply, okay? We're gonna start by converting from base 2 to base 10, okay? Let's say you have this value. You know it's in base 2. And the question is, convert it to base 10, and what's the answer? Okay. So this is the unknown. We can just leave it like this. Okay. So there are well, the way I typically approach this is like this, okay? So I'm gonna give each number a lot of space, and you have to remember this is like 11, okay? Because remember, does 11 exist in a binary number system? No. You only go from 0 and you only have the numbers 0 and 1 in a binary number system. Sorry if I said decimal in a binary. So the compiler reads this as just 1 and 1 because we're in base 2. This is why we focus number by number, okay? I'm drawing little boxes around to show that we're focusing on each number individually. Now, a cool thing to know, you can also view when we're converting to base 10 as from any base as taking this digit, whatever it is. And I'll say we have a base of B right here. I'll make it blue because blue is kind of the theme right now for this lecture. And I'll use red as like a tertiary color. I don't know why I said tertiary, it's the third color. Okay, so we take that number, whatever it is, multiply it by the base, raised to the ith power, with I starting at 0. So this would be I of 0, this would be I of 1, this would be I of 2, I of 3, I of 4, I of 5, and it would it would be increasing as you keep going. It's just counting, incremental, incrementation. This is how I'm going to view it, and I want to introduce I here because I typically means incrementation in programming. So even if this is your first time seeing an I here used for such a matter, make sure you remember it and understand it. This is the formula. So we're going to take, the whole idea here is you take that number, whatever it is, and I'm going to write it in a more formulaic term. Say digit, I'll say D, times the base, whatever that base value is, at its position. And then you're going to add it with everything else. So we do this formula, D times base to D 1 plus this, and then you keep going, okay? So that didn't make too much sense. I think you'll start to see what I mean as we get into this example problem, okay? So let's dive in. You remembering this formula, digit that we're looking at, times the base. I should make digit. Actually, we can make base black because the base is a constant thing, right? And then we can have the increment, okay? So this is a formula. So let's jump into it. Starting out, you start always from the most right number to the left. So you go from this to here. So we're gonna start with this number, right? This is 1. So our digit is 1 times our base, and I forgot to write it. We're in base 2 times 2 raised to the I power. Well, we know I starts at 0, goes to 1. Sorry, I goes from 0 to 1 to 2 to 3 to 4 to 5, and so on, incrementing by 1 each time. So that's going to be 2 to the 0th power. Well, what's that going to equal out to? That's going to give you 1. Okay, cool. We got that. Let me make this black again. And let me make this the next selected number. This is going to be 0 times 2 to the first power. Okay, yeah, remember it's first because our I is 1 now. We're incrementing by 1 each time. 2 times 1. Well, we know this is going to become just 0. Or moving on here to this next one. What? This is oh my god, that's the worst 2 I've ever drawn in my entire life. Okay, there we go. That's going to be 1. It's the selected number we're looking at, and here. To make it easy to follow along, I'll keep going, looking at the number we're selecting each time. Not mean to do that. 1 times the base of 2. Oh, I'm on the fill tool. Raised to the second power. So are you kind of seeing the pattern that's happening here? This is going to be 1 times 2 to the third power. This is going to be 0 times 2 to the fourth power. And what is this going to be? I'll let you pause and tell me what it's going to be. It's going to be 1 times 2 to the fifth power. So this simplifies down to 4. This simplifies down to 8. This simplifies to 0. And this simplifies to 32. The final step to convert is to simply just add all these numbers up, okay? We're going to do a little bit of adding. We're going to get 12 plus 32 is 46. 47 should be your number. And I can just check that real quick. 47 in binary is what? Yep. Oh, it looks a little bit different. I do something wrong. I must have done my counting wrong. Let me pull up an actual calculator and calculate this out this time. 2 to the 0th power is 1 plus 0 plus 4 plus 8 plus nothing plus 32 is 45. Yeah, I can't do arithmetic. That's kind of my folly. 45 in binary is literally, yeah, it's 45. I don't know where I got an extra 2 from. It's 45. I'm just going to be using calculators from now on. But okay, do you kind of understand this process and how we're utilizing this formula? D times base to the I. And another way you can look at it, still following this formula, it's just kind of, I'll use the same number. You know this in base, you know this would be what? 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. You can multiply the 1 and the 8, the 1 and the 4, the 2 and the 0. Well, 1 times 1 is just going to give you 1, 0 times 2 is going to give you 0, 1 times 4 is going to give you 4, 1 times 8 is going to give you 8, 0 times 16 is 0, 1 times 32 is 32. You can just kind of add them all up again, and you're going to get 45. Now that's like, we had this whole formula here. You can do it like this too. I recommend doing it like this first, get a problem still like this with the formula, with the numbers written on top, because you want to ease your way into understanding this concept, okay? Now let's move on to the opposite, converting from base 10 to base 2, or any other base, okay? And I just want to mention right now, conversely, the process would be the same if we had like 1, 2, 3, 4 in base 5, and we were asked to convert it into base 10. Now don't get confused or panic because it's a base in 5, it has all these extra numbers, it's not a binary. Just follow the formula. Your digit times your base raised to I, and we'll actually walk through this one pretty quickly because it's important for you to understand that this formula holds true, okay? Remember, separate your numbers. Because there's no 34 in base 5, there's only a 3 and a 4. Okay, follow the formula. You know it's going to be your 0th index, your first, second, third. It'll increase by 1 as you keep going out. Now what we're going to do is just d times base to the I. We know our base is going to be 5. Why did I say 5 like that? Anyways, this will be 4 times 5 to the 0. 3 times 5 to the first. 2 times 5 to the second. And 3, and sorry, where did I get that 3 from? It should be 1 times 5 to the third. Well, this is just 4, this is just 15, this is just 50, and I think 5 to the third is 125, that's 125. You add them all up, and then you're going to see that you get 175, 190, 194, and we get in base 10. This is the conversion, exact same formula, exact same steps. And I can also just make sure this is right, 134, or what do we get as the answer? We got 194. So I can just say 194 in base 10 to base 5. Yep, 1, 2, 3, 4 in base 5. That works. The formula works. The formula is true. Remember, and it works for all numbers. Just follow this. Okay? Just wanted to go to one more example to really make sure you understand that. Now we're going to swap over to converting from base 10 to another base like base 2. how do we go about this? And let me just real quick. Well, I don't want all that again. Let's just try like this. Base 10 to base 2. Okay, let's start right here, base 10. Let's say we have 136 and want to convert that into base 2. There are two ways to go about this. The first way is going to be kind of, it's like, I don't know there's even a name for it. I just call it the easy way. It seems kind of propagandic, but I mean, it's the way I want you to use on the test. And then there's way 2, which is integer division. And I'll explain this one because, I should. In a base conversion video, you go over integer division. I feel like, should there be spell division? Okay, yeah, there is 3 eyes. Okay, good. Okay. Anyways, yeah, there's 2 ways. I would not do this way unless you're really good at dividing numbers. I would do the easy way always, and we're going to start with that. So, if we remember, right? The easy way is kind of the inverse of the way we did before. So we know we want to convert 136 into base 2, right? Well, let's think about it. What values could go into one? Let's say, like, if we were making binary, if we had binary and we were trying to get to 136, how would we do that, right? If that makes sense. Well, there's going to be 2 to the 0th, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th. Whatever digit is in here, you're going to multiply with this and then add it with all this to get your answer, right? That's in the formula. Digit times base I. And then you just add it with everything else. I'm not going to use the summation notation because that's unnecessary. Anyways, yeah. This is the process that we're doing, it's kind of inverse. Well, okay. Well, let's think about it. If we're thinking about it rationally, right? 2 to the 6th is 64. And then here we have 2 to the 7th, which is 128. And alright, it's pretty useful to know they're just numbers. I wouldn't leave it like this. I would always write it like this on the test. You don't ever want to increase your chances for errors. Okay? So, I think it's pretty easy to understand if that's the formula then. Well, hey, we'd obviously want to, what can we fit, right? Let's say we have 2 to the 8th here, right? Well, if we had a 1 here, that means we'd have 256 plus all these other numbers in our final answer. And our number is literally 136. That's impossible. So there has to be, for 2 to the 8th is a 0. Now 2 to the 7th is 128. Well, is that bigger than 136? No. So we can't put a 1 here. This is totally okay. 136, and well, we're gonna have 128 now, right? 128 plus all these numbers, we know will get us 136. So then what should all the rest of these numbers equal to? They should be 8. So if we know that the rest of these values, when we put in our 1s and our 0s, needs to add up to 8, how can we do that? Well, is 64 bigger than 8? Yes, it is. That's going to be a 0 because we can't fit it. Because 128 plus 64 will take us over 136. Is 32 bigger than 8? Yes, it is. We can't fit it. Put a 0 because 128 plus 32 is bigger than 136. Is 16 bigger than 8? Yes, it is. So put a 0. 128 plus 16 is definitely bigger than 8. Or is bigger than 136, sorry. Is 8 bigger than 8? Well, no, obviously. So we're going to put a 1 here. Minus that 8 again, because now we're saying we have 128 plus 8. So now we have room for 0 more numbers. So automatically all this is 0. And you get an answer of 1 0 0 0 1 0 0 in base 2. Now I tried to show you through like reversing the formula that we know, like reverse psychology based off of, or not reverse, like just reversing the process, kind of like reverse engineering the formula that we used earlier. This thing, okay? The way I do it though is kind of like this. Oh, I have 136. Write out my places. Well, we know 128 is going to be here. 2 to the 8, 2 to the 7th, sorry. 2 to the 6, 64, 2 to the 3rd. And honestly, this is not how I do it. I would always start left to right, like in this direction. Start filling out here. You know, you have 1, 2, 4, 8, 16, 32, 64, and then 128. I'd be like, okay, we have 136. Well, what happens if we put a 1 here in 128? Subtract 128, which you can see we did over here. I'm left with 8 as my remainder. So I know that all of this must give me an 8. Okay, that's too big, that's too big, that's too big. Oh, that's just 8. Let's go. Minus 8 gets 0. And just fill in the rest with zeros. It's crucial you fill in the rest with zeros, okay? Because there's a big difference from, I'm running out of room. There's a big difference from 1 0 0 0 1 0 0 versus 1 0 0 0 1. Because he started 1 here, started 1 here. This would be way bigger than this, right? This would be way smaller than this. So don't forget those zeros. The zeros behind the last one don't matter because what? They're 0. They're not going to add anything. You know? So, yeah. Just don't forget any leading zeros. Kind of sig figgy, I feel like. Okay. And that's the easy way. Practice that. When you're doing conversion, practice that. And if we're looking at something like 136 to base 5, it's just generally the same thing. Like if I just, oh, sorry, I meant to just erase this. If we just make that a base 5 real quick, then what we can just do is the same thing. This is 5 to the 0 is 1. This is 5 to the first is 5. 5 to, that's way too close. This is 25, and this is 125, and we need actually one. No, one more would be too big. Okay, so I'll be like, okay, well, can we fit 125? If I place the 1 here, would that make our output following this formula? Would we get too big of a number if this was a 1? No, we wouldn't. So let's figure out 136 minus 125 is 11. Okay, we need 11. Well, if we have 11 left, 25 is too big. We can't do that. Can 5 work? Yeah. Can 1 work? Yeah. But see, if you're solving like this, following within binary, you might be like, oh, wait a minute, you're cooked. That's only 6. You're gonna have a remainder of 5 left. This is impossible. Sid, you lied to me. But you have to remember when we talked about number systems, binary only has 2 digits. Binary has 0 and 1. That's all we can work with, okay? But whatever 5 is, base 5 has 0, 1, 2, 3, and 4. We have way more numbers to work with. Don't just limit yourselves to 1s and 0s if you're trying to find base 5 or any base like that. Use all the numbers in your number system. You will probably most likely have to. So what we can do is if we want a remainder of 11, we can set this, and you know what, I might even just, because it's kind of new, right? Make this into a 2. So we left 10. 11 minus 10 is 1. So we can just set this to 1, and then our answer is 1, 0, 2, 1 in base 5. And I can fact check that right now for us. I really should do this before 136 to base 5. I have to go on a base converter. 136. 1 in base 5. It is 1021. Exactly as I said, that's it. As simple as that. That's how you do it. This is the way. This is the easy way of base conversion. Know this way. Understand we talked about going from on lesser base to base 10. A lesser base. Talking about going from this to here. Now we need to, and also if you had, I didn't touch much with hexadecimal, we talked about it. Up the way to F. Same principle, you would just, if I needed 16 or something, right? Or if we're converting this, just like remember, here, I can erase this, talk about hexadecimal a little bit, because you're probably going to see it, and you need to understand how it works. Converting from base 16 to base 10, follow the exact same formulas. Just remember that A represented as the actual number 10, B is the number 11, all the way to F is the number 15, okay? So if I gave you AF in base 15, I wanted you to write that for me in base 10. Let's follow our formula, your digit times base to the I. I'm sorry, base 16. I don't know why I'm out here saying 15. It's the exact same steps we've talked about. F, don't let that trick your brain, view that as just the number 15. So we're saying the number 15 times 16 to the 0th power, which is just 1. A, don't let that trick your brain, just view that as 10. We're saying 10 times 16 to the first power is 16. Add them together and you just get 160. So I just make sure you're familiar that don't be scared when you see letters, when you see A or B or C or D or E or F, Make sure you understand what they mean. A is 10, B is 11, C is 12, 13 is, C is 12, D is 13, E is 14, stuff like that. Make sure you understand that, okay? Now we're gonna get to the second way of doing this conversion. I'm only gonna do one problem, focusing on this other way, because to be frank, I don't like it very much. I don't think this is a good method to use. Maybe if you have a calculator on hand, you could do this method. Maybe then it'd make more sense. Or if you're writing in code, I could see, like algorithmically, this might be easier to do. Definitely easier to do in an algorithm. But for ULCS, we have limited time. You don't get a calculator, by the way. Everything you have to do is your own arithmetic. This other way can get kind of weird. And you're prone to error a lot more. Let's look again at 136 converting to base 2, but now we're going to use the integer division method. So what is that? Take your number, we're going to divide it by the base we're trying to convert to. We're trying to convert to base 2 divided by base 2, okay? Potato, tomato. And then, if there's a remainder, we want to store whatever the remainder is on the side, okay? Sidebar it. Just write it down here, but keep going with this process. Do num over base, right? Whatever number that gives you is your new number. You're going to do num over base again. The cycle repeats, and you keep on storing your remainders each time. Okay, so let's actually go over this. Now, again, I stress don't use this method on the UIL CS test, but I know a lot of base conversion videos talk about it, so I feel like I should talk about it, but I do not like this method. Use easy way, practice easy way. Easy way is a lot easier. Once you understand it, it's a lot easier than this. Unless you're really cracked at division, and just do this, I guess. So we're gonna do 136. Remember, we're converting it to base 2. Stick a 2 here. Now, I'm just gonna use my calculator so I can avoid me making mistakes, like silly mistakes. It's gonna give, so 136 divided by 2 is 68. Sidebar the remainder. Well, if there's no remainder, then the remainder is 0. Okay, cool. Keep on going. 68, remainder of 2. So, or 68 divided by 2, sorry, is 34. Is the remainder anything? There is no remainder, so we're just gonna have another remainder of 0. 34 divided by 2. Instead, we're taking this number and we're continuing the dividing with it, okay? I know that one. That's 17. See, hey guys, even I got that one. Let's go. Alright, keep on going. 17, yeah, that's clean. There's no remainder. 17 divided by 2, however, is where we're going to start to see a remainder. We're going to get 8, and we're going to have a remainder of 1, right? Because 8 times 2 is 16. 17 minus 16 will just give you 1. Remainder of 1. Keep on going, though. Just sidebar your remainder, put it to the side, and keep on going with that number. 8 divided by 2. What is that? That is 4. We're going to write a 4 here. Remainder of 0. 4 divided by 2. What does that give you? That gives you 2. Remainder of 0. 2 divided by 2. Okay, what is that? That is going to give you 1. Remainder of 0. And lastly, 1 divided by 2. Well, what's the biggest thing we could multiply 2 by that could fit here? 0. There's nothing else. 1 is literally smaller than 2. Whenever situation like this, you always get the dividend, I think, or no, quotient of 0. So you're going to get 0 with a remainder of 1. And if you had a situation like this, you won't have a situation like this. I guess I don't think you will. It'd be, I guess it depends. But you'd have a remainder of 3, okay, whatever's inside. Once this is 0, that's your remainder. It's just division. Arithmetic. But anyways, this is the process that I'm trying to go over, not necessarily the math component of it, but this. You're storing your remainders. You've been sidebarring them. You may ask me, Sid, what do we need these for? Well, we're gonna write them out now, okay? Starting from this, moving all the way down, okay? We're gonna write 0, 0, 0, 1, 0, 0, and I think there's one more 0, 1 in base 2. That'll be your answer. Let me fact check that right now. Okay, 136 to base 2. Yup, it is that number. We're good. We're in the clear. We did it right. Now, you might be saying, I said that I actually like this method. You know, the dividing wasn't that hard. Yeah, I gave you 136. What if you had 277 or 319 or weird numbers that don't seem to divide easily and are big? What if you have 567, you know, or 567? I don't know why I said it like that, but like, yeah, you have these numbers, right? That's not so easily dividable. Now, is it easily subtractable? Yeah, it is. If we use the easy way, if you use this way and we had a problem that was like 567 in base 10 base 2, this way would take a long time. It's integer division. You have to do a lot of dividing, and chances are you'd mess up somewhere. You'll spend a long time doing all this dividing just to not see your answer. So if we're looking at, if however, we are going to do 567 in base 10 to a value in base 2 using the easy way. Okay, let's write out our values. 1, 2, 4, 8. I don't like that 4. It's kind of like out of place, you know what I mean? 4, 8, 16. I guess both 4s don't matter. 32, 6, because a 4 is a 4 no matter how you look at it. Even if it doesn't look like other 4s, it's still a 4. 256, and then lastly, 512, right? So we have all these numbers. Okay, let's just do this method. 567. Does that, okay, if I put a 1 here, will that fit? Will this give me a number that's too big, bigger than 567? No, 512 is smaller than 567. Okay, cool beans. Let's do our subtraction now. Let's see how much more numbers we're kind of working with. 5, 5, 0. We're left with 55. Okay, well this is too big, and this is a 6 by the way, in case you couldn't tell. That's too big, that's too big, that's too big. Oh, this is small enough. That's cool, let's use it. 55 minus 32 is 23. Yeah, see, we can fit a 32 here, cool. Can we fit a 16? Oh wait, we can. That's gonna be 7, I think. Hopefully I didn't do any of my math wrong. I mean, there's no way, right? What? Okay, well, 8 can't fit. 8 is bigger than 7. 4 can't fit. Okay, now we just need, we have 3 left. Is 2 smaller than 3? Yes, it can. So if we put a 2 here, that'll still work. We're left with 1. Boom, 1 right there. This is your answer. 1 0 0 0 1 1 0 1 1 1 2. And I mean, if you're not talking, if you're just doing it, that might just take you a minute. You know what I mean? Like that's not gonna take you that long. Versus division, dividing this weird number. Who knows what it'll divide into? You don't get a calculator. You don't get anything. You have to just use your arithmetic. Well, you get a paper and pencil and stuff, but still, this is a lot more easier. What would you rather do? Subtraction or division? You know what I mean? Don't do integer division on the test. It's not worth it. Never worth it. Now, the last thing we're going to cover, and I just want to preface this video going over the first section. We're going to have 2 parts. This first question is over conversion. The second part I want to go over is arithmetic basis. So adding, subtracting with different bases. I mean, it's 99% conversion, but you have to know how to subtract or add and divide and stuff when binary and stuff like that. You should have to know that for the test. That's what we're going to cover in arithmetic. And then this is conversion. So it's going to be split into 2 sections. Now this is the most important part of this entire video. So far in this video, we've talked about taking a number from base 10 and then converting it into base B, or the opposite, going from base B back to base 10. Okay, but that's not all they're going to test you on the UIL CS test or written section, okay? You could get a number like 1001111, and then they want you to convert that into base 8, okay? Or vice versa. One way you can do this, which is an incredibly slow way, is taking this, converting it into base 10, and then taking that value and converting it into base 8, or vice versa if you're going this way, from base 8 to base 2. This is slow. Remember, you only have 45 minutes for 40 questions, okay? I want to introduce you to a fast way, which I call the powers of, 2 method. Okay, so what is this method? Why is it called the power to 2 method? Because it only works when you're converting from a power of 2 to another power of 2. So base 2 to the base 4 works, base 4 to base 16 works, base 16 to base 2 works, base 16 to base 3 doesn't work, okay? So it can only be between bases that are powers of 2. And here's how we approach it. Let's write out a number, 0, and I'm going to write them as individuals as you do. And we want to chunk these numbers into groups, okay? Why is this the case? This relates to the principle that in base 2, what we talked about earlier, base 2 can only store zeros and ones. However, base 8 can store 0, 1, 2, all the way up to 7. And remember, I actually mentioned it was interesting how it only goes up to 7, right? This is incredibly useful for this method because essentially we're going to chunk groups that would give us up to this maximum value of 7. Okay? So, what does that mean necessarily? Well, we know 2 to the 0th power is 1, 2 to the first power is 2, 2 to the 3rd power is 4. What does this equal? 7. Chunk it, draw a line, little wall separating the two sections. 1, 2, 4. The reason we draw our line wall here, well, here, I'll follow along me here now. I have an explanation for this, but I want us to solve this and then I can give you the explanation. What are we going to do now? We're going to multiply, okay? We're going to say 1 times 1 is 1, plus 2 times 1 is 2, plus 4 times 1 is 4. That will give us, and we'll come back to that. Remember, wall, blocker, right here, okay? 1 times 0 is 0, plus 2 times 0 is 0, plus 4 times 1 is 4. Add these up again, you get 7. Add these up again, you get 4. Remember, it's a wall. Why is this wall so important? You must understand that these are going to be two separate numbers. You don't add them together to get 11, no. You stop right here, and your answer is 47 in base 8. This is the power of 2's method, just this. Now I said I'd give you an explanation for why we're stopping here. Why did we draw a line at 4? Okay, power of 2, 2 to 0, 2 to the first, 2 to the second. I understand that's in the name, yap. You all listed. Why are we stopping here? Well, if we kept going to 8, right? And let's say we chunk it here. We chunk it there. What's the biggest number you can have in an 8 number system? 7. But if we're adding this 8 and we're following along these steps, let's say this was a 1. Even if all these were 0, you'd have an 8. And 8, that's impossible. You're breaking the number system. So we limit ourselves. We stop right at that 4. We stop here. Because even if these are all 1s or all 0s, we still get 7. Okay, which is less than 8. This is in the number system. 7 of base 8 works. If we were going to 16, we would stop right here. Because the sum of all this gives you 15. 15 base, F base 15 is the highest you can go. If we added one more, if we, let's say, delete this wall, we added 16 and then we put the wall back. Oh, well now, even if all these were 0 and this was 1, we're trying to say we have like G of 15 or G of 16. I don't know why I was referred to 15. It's hexadecimal 16, okay? Hexadecimal is 16. we're saying we'd have g of 16, which is impossible, okay? That's the importance of this. It's to ensure that when we're doing this conversion, we're not cheating, we're not breaking any rules, okay? Hopefully that makes sense. Now, this is the way through here. It's just the wall, then you just multiply. And you just add, multiplying and adding, nothing new we haven't seen yet, you know? So you should be, this way hopefully makes sense. It's just multiplying and adding. The key indicator is the wall. Make sure you remember there's a wall there. We can't bridge if we're going from base 2 to base 8. You cannot, you have to stop it after this 4. We can't have an 8. Remember, it breaks the rules. You have to wall it off, restart back at 1, remember, and keep going. This ensures that we get proper accurate groups, okay? Now let's kind of flip the script. I want us to talk about converting, let's say, now we haven't had many examples, okay, that deal with hexadecimal numbers. Let's look at this number in base 16. And, excuse me, I'm gonna ask you for it in base 2. Okay. And you can do it with base 4 and stuff. From what I've experienced on the test, you're not really gonna run into something like this. If there is, like if I find a problem about it, maybe I'll include in the practice and show you how this method works. Or if this method for some reason doesn't work there, which it should work, I'll update this video. But let's go over this. So we have A, F, 6 in base 16 hexadecimal, and I want to convert it into base 2. So the exact same process, except remember how we were reverse engineering it to go from base, base 10 to base 2? It's going to be the same thing here. We know our final output is going to be A from one set of numbers, 8 from another set, F, and then lastly 6, right? And the reason why we're doing these walls is because remember, the walls indicate where you kind of stop adding, and this is one value, this is another value. I went over that earlier, which is why you didn't add the 4 and the 7 together. There was a wall there, showing that there are two separate values. It's not 11 base 8. No, it was 4. It was like 4, 7 base 8. Okay, same thing here. We're adding in these walls here, so you're not adding these numbers together. Okay, let's write our little top bits. So 1, 2, 4, 8. Remember, you can't go to 16. Wall it in, which we already did. 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. Okay, and now for this one, A. What's A? I'll write in the bottom as 10, 15, because I know you're still understanding this concept. Or maybe you already know it, but if you're new to this is still kind of new, you know? I'll write in red, we already have this. Red is the tertiary color. So, if we're converting it to binary, remember, if we're looking for a formula, it's digit times whatever it's above. If you're a digit here, you'd multiply it by 8. A digit here, you multiply it by 4. A digit here, multiply it by 2. Okay? And then you just add it to the other digits in there. So if we did digit multiplied by 8, add it to the digit multiplied by 4, add it to this digit multiplied by 2. These are all different digits, by the way. Okay, cool. So if we know that that's how we're going to get A, what should our digits be? Well, can we fit a 1 here? Oh, this is nice. This is literally, wait, guys, this is literally just converting from base 2 in a way to base 10. It's the exact same process, okay? Except we're trying to limit it, you know. We have 8, or we have 10. Can we fit if we have a 1 for 8, will we go over 10? No, we won't, because if we do 10 minus 8, we will get 2. So we can have a 1 there. If we have a 1 for 4, will we go over? Yes, we will. Put a 0. If we have a 1 for 2, will we go over? No, we won't. Put a 1. 1 for 1, we won't go over. 1, 0, 1, 0. Repeat that process if we have a 1, but now we're looking at 8, okay? If we have a 1 for 8, will we go over? No, we won't. In fact, we will just reach it. So we'll have 8 minus 8, which is 0. So all these other values, remember, you must set to 0. We set them to 0. Don't ignore it. It's not 1. No, that's wrong. It's 1, 0, 0, 0. And that's because each of these numbers represents 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. If we're just saying you have 1, you know, this is not the same as 16. Okay? Just want to make that point known again. Why am I hitting redo? Okay, F. Exact same thing. Can we fit an 8? We can. Can we fit a 4? We can. Right? 15 minus 8 will give us 7. Does 4 fit in a 7? It does. We're left with 3. Can we fit in a 2? We can. We'll be left with 1. Can we fit in a 1? We can. Cool. No, it's fine if the 1's a little bit bigger. Doesn't really matter that much, let's be real. Now let's move on to the 6. Can we fit an 8? No, we can't. Can we fit a 4? Yes, we can. 6 minus 4 is 2. Oh, we got it. We can fit in this 2. It fits. Can we fit in a 1? No. 1 is bigger than 0. So that is 0. And this right here is our output. The answer to our question is this line. 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, 1. Oh, let me clear some room for us here. And let me write this out. Just 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 1, 0, 1, 1, 0. And trust me, once you familiarize yourself well with this method, it's going to be a lot, and I mean a lot more faster than taking this number, putting in base 10 and converting it back to base 2. Okay? And then I know now that I've kind of connected the dots, how this is essentially just, this step we're doing here is essentially just converting from a base to base 10. Or sorry, from converting from base 10 to a base. It's the exact same process that we did over there. Then I understand. I have full faith this will work for anything. Remember how I went over that example with base 5 and stuff? Yeah. So if you had like 16 to base 4, okay, maybe this one is a 3 now. Maybe this one's a 2. The exact same process, okay? And I use a lot of binary examples here because you're going to see binary the most. Octal, hexadecimal, and binary and decimal are I feel like the most prevalent number systems that you need to know. This is it for base conversion. I talked about everything I wanted to. Maybe in the next video for arithmetic, no, probably in the practice video I might cover this with more weirder bases, like 32 maybe, and vice versa. Just so you can get that practice in, because it's it's easy to do this, but a little bit harder to realize that maybe I should make this a 3, maybe I should make this a 2, you know? And that's an important skill you want to understand. So I'll probably do one practice of this in the practice video if I decide to make that. Otherwise, so you can just practice it, you know, just make your own problems, of course. ULCS is gonna, your score in UILCS is dependent on how much effort you put into it, right? They have a positive correlation, you could even say. And I'm making this course because I don't want your work A lot of times, at least for me, it was like this. I'd work this amount of time for like this amount of benefit because I was looking at the wrong things. I didn't understand resources and what I should have learned. With this course, it should be more linear or maybe even exponential. But yeah, so what have we covered today? We covered going from base to, we've covered from going, so we talked about the number systems. And here, actually, let me just, don't say, so here. We talked about the number systems, the common ones you need to know, how they work, what they mean, stuff like that. Talked about the basis, subscript, all that stuff, like binary has a number in base 2. So that's number systems. We talked about converting from a base, a number in in any base, like base 2 or something. We talked about taking that number and converting it to base 10. Then we talked about the reverse, taking a number from base 10 and converting it into any base, which you also do for the power of 2 method, which I'll just. We also kind of touched back on this, pretty much very recently in the power of 2 method. And then also, we talked about converting from any power of 2, so like I, to any other power of 2. You should be able to do this. If I and, let's say, B were a completely different value, I'll make this like V, I feel like it's good. If I'll make it J. I like to use J. It's my second increment sometimes. But anyways, no, this is just variables. Like let's say I is like, this is like 2 to the base of 2 to the 12th, and this is base of 2 to the 15th or something. Whatever this value is your base. And then whatever value this is your base, right? If you'll be able to, the whole point of this is like, you can convert from one base that's the power of 2 to another base. And here I'll make this an arrow sign. That is also a power of 2. That's the whole point of this method. And you'll be surprised how common they test you on this. You make sure you study this power 2 method. And I think that was what we've covered. This is again part 1 to the basis video. The second one will come out and it'll be over arithmetic. You know how to add and subtract your bases. It's gonna be a lot shorter than this one. And you're probably we're gonna do some conversion, but I'm not gonna go over it in detail as I have here. You can also just do that as conversion practice. But arithmetic is important. You might see a problem like 110 base 2 plus 84 base 8. And then they want that output. And they'll give you like A, it's 53 in base 5. B, it's 62 in base 7. C, it's 148. I don't know if they put the subscript 10 or not. Either way, it's 10, base 10. D, none of the above. Or even E, they might sometimes you'll have all of the above. You know what I mean? D above. Right? You have to understand how to do this arithmetic, which we'll get into next time. But this is the first part of and really the first real deep video that actually goes over concepts to be tested on in your written test, okay? Sorry if this one was long, there's a lot to go over binary. Even though it's one question, there's a lot in it, you know what I mean? And it's also an important concept to know in CS in general. If you need any reviewers, I can send other videos, kind of tired right now, so it'll probably be in the description later, but I'll add the script in the description of the video so you can look to for guidance. Because understand I'm not the world's greatest teacher at all times. I'm just a student learning. But yeah, that's it. This is URL CS tutor signing out. I don't really know if I'm gonna have an essay. Let's end the video now.